you get which one is it? 45 or sorry, 40. Did you get 45 right?
Yes.
I think I
Okay.
No.
got it.
Just crossed it.
Yeah. So I did
I
read
don't-
that. The right answer.
Okay. Hi, Jonah. Hope your volleyball tournament went great. What's your question?
So, 1.4 is page 46. 46 and 47.
Page 46, number 47.
Page 45, number 46.
Yeah, 45,
And
46.
46, 47.
How fun. Okay. Which one do you want to do?
So, I don't know. I think I was just stuck on like the concept of like what does it mean by evaluate G prime of 37?
So, like, plug 37 into G prime and find what that value would be.
Which we're given G, so we have to find G prime.
How do we find the equation for G prime?
So, you guys we have discovered this already. If you have a linear line, what's the rate of change?
Oh,
It's
nothing.
the slope. It's
The slope, not nothing. The slope. So our slope is the rate of change on a linear function. For 46, that is
-2.
-2/1. So what will G prime of 37 be?
-2.
Yeah, -2/1.
Oh.
Because the rate of change is the same everywhere on that linear function. No, so it doesn't matter. I could ask you G prime of any number in existence, and you could tell me it's just going to be -2.
So the final formula for G prime of Z would be
G prime of Z. G prime of 37 equals -2.
and that's the entire equation because it's just linear.
Yep.
And the formula for G prime of Z is just -2.
And then
Yeah.
so that would be part B.
Oh, okay.
That
So
makes
then
sense.
47.
Okay, 47 is going to be different, but
Yeah. So that was the other one I had.
okay. F of 1 is 5, but we had graphed F prime there. We want to find an equation of the line tangent to the graph of F at the point 1, 5. So they tell us the point on F where the tangent line will cross. And we want to find the equation of that line, of that tangent line. We can look at G prime and figure out what that slope's going to be on the tangent line.
1, 5.
Just one.
Oh.
And
So
then whatever
the
that.
slope is going to be.
The slope is the y value at that point. So it's the prime function, that's not the actual function.
Oh, so the slope is 2.
It's 2. Yep. So on F, the slope is 2 at the point 1, 5. Okay, so we have a slope, we have a point on F. Can we use that to make the equation of the tangent line?
It would be y equals 2x plus.
You'll probably want to use point slope form and then put it into slope intercept form because we have point and slope information, not necessarily the slope and the y-intercept.
The y-intercept's not too hard to find though from 1, 5. Y-intercept's not too hard to find from 1, 5.
Yeah, that's true. You can
If
just think
it's
about it
2.
too. Yep,
So,
that also is fine.
So 1 would go.
Drop picture. That'd be faster.
Slope is 2.
Slope is what?
1. Is there 2?
Slope is 2?
Yeah.
So So it would cross at 1.5.
Cross it. Should cross at 3, I think. If you go back 1, you'd be at the axis, and down 2.
Back 1, down 2, back 1, down
If you plot 1, 5,
2. Yep, so it'd be right here.
yep. You're crossing the x-axis, you go over 1, and down 2. That's your intersection, right there.
Oh, it's your y.
Y-intercept, yeah.
So it'd be,
Oh yeah, x-intercept would be things.
yeah. To get y equals mx plus b.
B is your y-intercept, yeah.
So it'd be y equals 2x plus 3.
That's what I had.
There you go. Better?
Yeah, that was the only question I had.
Okay.
So the slope.
Did I tell you to do 48 in the homework?
No.
No. Okay. Should have. Oh well.
So the
That
slope
was easy, so.
you can find on the slope is just going to be the slope of the f function at a certain x point is going to be the y value at that
Of f prime.
of f, right?
Yep, because what is f prime? When we think derivative, we want to think rate of change. When we think derivative, we want to think slope. Those are the same thing. The derivative function, the graph of that, is telling us the slope at every point along the way. Because it's just a slope. It's a slope function. Yeah. Okay. Did you have any questions? Or okay. All right. Let me. Shoot, that's not gonna work. Okay, that's okay. I just need to check this real quick. Okay. Okay, let's do our memory work. What is calculus?
Calculus is the study of
No, okay. What is calculus?
Calculus is the study of change, both instantaneous change and the accumulation of change.
And then what does Ecclesiastes 3, 9 through 14 tell us?
What gain has the worker from his soil? I've seen the business that God has given to the children of man to be busy with. He has made everything beautiful in its time. Also, he has put eternity into man's heart, yet so that he cannot find out what God has done from the beginning to the end. I perceive that there is nothing better for them than to be joyful and to do good as long as they live. Also, that everyone should eat and drink and take pleasure in all his toil. This is God's gift to man.
Okay. And why should we study calculus going?
Riverbanks?
Yeah.
Riverbanks?
The curve of a riverbank.
Okay, here we go. Come on, zoom in. Alright, it's not zooming in. Can you read it?
Yeah, it's fine.
Why should we study calculus?
The curve of a riverbank, the wandering of the planets, and the swelling of the tides conceal eternal patterns. Calculus is a discipline that allows us to behold these patterns and perceive their unchanging laws. Nature is a realm of movement, growth, and change, and calculus assists us in understanding these changes with precision. Thus, we learn calculus not merely to calculate, but to see the necessity and the beauty of the truths that govern change, and thus to live well in the midst of change.
Alright.
Can
I
I ask
won't-
who that, like, who wrote that?
Me.
Oh, cool.
Yeah.
Nice.
Thanks. So I want to redo these notes with you guys. Just real quick. This should say verbally, if you really care. I'll give you a second to do those notes. Okay, and then back to Calculus House. I brought my notes this time, so I actually have all the things I want to say about it. Okay. Okay. We have our shortcut summary of everything we've seen so far about how f prime, and f double prime relate to each other. It tells us that if this is a feature of f, then that this will be a feature of f prime. And if this is a feature of f prime, it'll tell us a feature about f double prime. We can use this to kind of figure out, we can use it as a shortcut to think about the features of f prime, and f double prime. We could just think about it and we know how to do these. We've been doing them for like 2.5 weeks. But this is a nice shortcut summary. Okay, notice right here. Oh, come on. Stop messing up. Here we go. I just gotta draw. There we go. Right here is the only spot where we have all 6 of these rooms together. Okay. This has all the features. It has positive, negative, increasing, decreasing, concave up, concave down in those 6 rooms of our house. And nowhere else do you see that exact thing. If you can remember these 6 boxes, you could really figure out the rest of the boxes, right?
Yeah.
Like if you have concave up, concave down, matched with those other sets there, then you could be like, oh yeah, I just know I could fill in the rest of the rooms of this house. So really, if you can remember those 6, or if you just remember like a row of 6, then you'll be able to fill in the rest of the rooms of your house. A lot of students on the AP exam will right away, as soon as the test starts, will just put this, 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 this at the top of their page as soon as they're allowed to start writing, so that they don't have to think about it for the rest of the exam because their shortcut is right there. So as we continue practicing using these features, keep referencing your calculus house, think about this diagram, try to help shortcut those so that we can be efficient with noticing those features as we keep going. Okay? Make sense? Great. Also, we could keep going. Could there be a basement to this house? Yeah, we could take the derivative of f double prime. We could take the derivative of that. We could take the derivative of that. Yeah, we could just keep going.
Switch 2 pools. No,
Yeah.
4 pools in the second basement.
Yeah. So this could keep going. We could add basements to several basements, many infinite basements
So many
to
basements.
our calculus house.
Infinite hollow basements.
Yeah. Yep. Okay. Did you have any other questions about calculus house or anything that didn't make sense? Okay. I could do that. I don't think I will. Okay. And then we were working on these. We were grading people. So we finished talking about this one from the AP exam. And we said, nope, no points on this one. You did a lot of things correct, but you don't get any points because there's no mention of A prime. No mention of A prime. So that's why they get 0 points for the first one. They have A of 1, but they don't tell us anything about A prime. They don't even tell us they tell us the rate at which the vehicles arrive is increasing, but they didn't say anything about A1, A prime of 1. So there's no points for that. And if you don't earn the first one, you don't earn the second one. Okay, let's look at, I wanted to look at number 3. Let's look at number 3. Let's grade that one. Take a minute to look at number 3. You have also the scoring notes in your packet. How would you get scored if this was your work on the AP exam? Or do you have any questions?
What is a toll plaza?
So here's the original. A toll plaza is like those spots where you have to go pay the toll while you're on the highway. Yeah. There's the problem prompt. These are the scoring notes.
I'm just being a little cheeky. I live in Iowa when I got tolls.
Yeah, right. Isn't that a blessing? Do they have them in Colorado?
To get to the airport, there's totally gets you around Denver. It's totally worth taking.
Okay, good to know. If I'm ever in Denver.
But you go every time.
All right, any thoughts? Any observations? Questions? Sarcastic comments?
He gets 1 point because he said v of t, the first derivative, or just like f prime is positive, so it's increasing. So he considered a prime of 1.
He considered a prime, but he didn't call it a prime.
But he called it the first derivative,
He called
which
it the
is
first
just a
derivative,
prime.
right?
I
But like,
get
would you
what
get
you're
points off for not notating that correctly?
So he or she, what they're doing here is a of t to v of t is like how we did our acceleration, velocity, and position functions.
Yeah.
It's actually totally valid. You can name functions whatever you want.
Okay.
So that won't lose
Yeah.
the point because he called it v of t.
Okay. So then, yeah, considers that and he answers for the reason. So.
Okay, my question is here. The first derivative of what?
Oh, it could be the first derivative of f prime, so then it'd actually be f double prime. He didn't say it's the first derivative of f.
Of a. Of
A,
t.
sorry.
Yeah.
Or v, right?
They have it as a of t in the prompt. So it doesn't say what the first derivative of what is. So because it's just so close but technically vague, it's actually not going to get this point.
So he's gonna get 0 points total.
Yep. First derivative of what is why he's going to lose that point. Now,
A prime would just
now
be
if he made
easier to
one
say.
small change, to us we understand. We're like, oh yeah, like we're tracking. His work is all completely correct. But because he wasn't specific enough about what was going on, they'll actually score you 0. So this is, I am showing you guys this because I want to show you like the way that we talk in class and the way that we write our answers in class really matter. That's why I won't take double f prime or whatever you used to say. It's f double prime because the way that we talk about it matters. If he made one small change and if he called this a prime of t, then even though this is what he wrote here, he would get full points because he wrote a prime of t instead of v of t. You can write v of t, but then you have to be very clear. V of t is the first derivative of a of t. And then great. So if he just made like a couple small changes, then you would actually get all the points out of it. Okay? Let's look at number 4, and then we're going to move on. Take a look at that work. Also with number 3, you guys will learn how to do this step sooner rather than later. So, anyways, but let's look at number 4.
Yeah.
I
You
give
get
full
both
points.
points.
You give him full points?
Considers a prime and gives the reason.
Give him 2 points.
It says, oh, okay. Gotta organize myself here. Okay, you would give him full. Let's just talk about the first point. You would give him the first point because.
Considers a prime.
Okay, he considers a prime.
He literally writes out
Yeah.
a prime and then what it is.
The correct answer is there. Like it's almost exactly like the scoring note right here. It pretty much is exactly the same. It is rounded to a different decimal, but that is fine. So he even has a correct answer. Okay, so he gets the first point. So we're eligible. We're eligible for the second point. Come on, what are you doing? I don't know why it does that with printouts sometimes. Okay. So we got the first point. Let's talk about the second one. This is the first time we've actually had to consider the second one. Why would you give him that point?
Because he gives the reason, says the acceleration is positive. And that's why it's increasing.
Okay. I actually would not score him as what, nor would AP. This is the issue. What is a prime representing? What rate of change does it represent? Not time. We do plug time in as the independent variable, but what is our rate of change in the problem? We have to look back at the problem prompts. But what would A prime represent?
Would be like the quantity basically of
Cars per
vehicles.
hour.
Yeah, like how many cars are arriving at that time? So the rate of change of the cars, is that acceleration?
No.
No. So actually, because he's mislabeled what A prime is, then he's going to lose that point because he didn't give a proper reasoning for A prime. So that would be 0. Now, if he just didn't write and he wrote the rate is increasing because A prime of 1 is positive, then he would get the point. So it's these little ones, the little ones that matter. Okay? So I don't want this to be like discouraging, but just to like start highlighting like what we're aiming for. We're aiming for very accuracy and precision in every answer we write, on every exam that we do that I give you in class, and every homework, like that we want accuracy and precision. So that when you get to the AP exam, you're not like, is this accurate enough? And so, yeah. Okay? We won't do the rest. If you want to score the rest on your own sometime, the answers are on like this sidebar right here. So then you can try to figure out why they would score it that way if you want to do that on your own. Okay? Okay. We are going to move on. Yesterday you watched the video. How did it go? Make sense? Any questions?
Yeah, no.
Okay, you got your notes filled in for that.
Yeah.
We're
Okay.
gonna do what? 1 through 6?
Yeah,
Get 1 through 6 and then 15, 16, 17, or 14,
Yeah.
15, 16, something like that.
13, 14, 15, 16.
There it is.
I don't think we had to do 16.
You didn't have to do 16. If you did 16, great. You could totally do 16. I just didn't make you.
I did 16.
Great. I did 16 on my notes too.
Is it 1 over x squared plus h?
Plus xh.
Yes. Plus xh.
Do you have a negative? Is your fraction negative?
Oh, shoot. Yeah, I didn't.
Because you'll have a negative h on top,
Yeah.
right? Yep. Okay. Okay. Let me see. I don't have this on OneNote, and it'll probably take too long. 13. What'd you get?
13. We got 2x plus h plus 1.
You get
2x plus h plus 1.
That's what I got.
on 13.
I got 2hx plus 2h minus 2x plus h.
Okay. Let's go. Okay. So f of x plus h. Did you start here, Michael?
You have like x plus h squared minus x plus h squared.
When you FOIL this, what do you get?
I got x squared plus 2hx plus h squared minus x plus h.
Minus x minus h.
Yep. Minus x minus h. Wait, minus x plus h, right?
Nope, so this
Minus x
negative
plus
is
h.
attached by multiplication here, so we're gonna distribute this negative.
Oh, no, because
No, yeah.
it'd be minus. No,
Because we're
minus.
subtracting that whole quantity.
Yeah.
So we're gonna subtract
Okay, yeah, that's right.
minus x minus h.
Minus x minus h.
There's like a -1 right here in the front.
Oh.
So we have to distribute that -1.
That's what I missed.
So then it would be okay. Then this is
Yep.
here.
Almost had it. I'll see here. So
Yeah.
close.
-1.
Yeah, -1. Okay. All over x plus h minus x. Okay. Gotta subtract f of x. Okay? Yes? You good with that, Michael?
Yeah.
Okay, then we also have to distribute this negative too.
It'd be negative x squared plus x.
So I'll just rewrite that. Minus x squared plus x. Okay, so then what cancels?
X squared plus x's.
Okay, and also on the bottom, the x's. So then we have 2hx plus h squared minus h over h.
So then it's so that ends up being okay, that's what I had initially. So it's h squared plus 2hx minus 2x minus h over h.
Where do you get 2x?
From it's because I forgot to do the negative, so instead of canceling out my x's, I added them together as two
Okay.
negatives.
Yep.
So then that gets rid of that.
Mm-hmm. Okay,
Is that just
great. And then now it's easier because we can cancel an h from every term. Because we have an h in each term. So if we just factor it out, we can cancel it.
That was my problem.
So now I have this, and that's about as simple as you can make it.
H plus 2x.
This is why I failed calculus.
You took calculus?
Yeah, I dropped it before I got a W instead of an added. Because my algebra was so bad I couldn't do this.
That's too bad.
It's okay. Push me into history instead of chemistry.
There you go. You have to take calc for chemistry.
Yeah.
I know you have to take calc for biology, so I guess it makes sense. Okay, that's 13. So 14. Do you have to redo that one? What did you get?
I square root of x plus h minus square root of x over h.
So I had as well.
Yeah.
Yes.
Great. That was honestly way easier.
Yeah.
That was super simple.
Yep. And we don't even have to like simplify those radicals because they're already in the numerator. If they were in the denominator, you'd have to radicalize the denominator,
That would be fun.
and then you'd actually just end up here. But okay. Awesome. 15.
4x plus 2h.
4x plus 2.
You didn't distribute negative or something.
I have negative 3x squared plus 2hx plus h.
You also probably just didn't distribute a negative. If you're keeping your x's around that much. If you have an x squared.
Over h.
Okay, let's do 15.
Should be negative 4x plus 2h, sorry.
3 minus h squared plus x. Should be 3 minus.
I should also be minus. They
So
should
3
both be.
minus x squared plus 2hx. Oh, all of these are negatives.
Yeah, that's what I
So the entire thing is minus.
So negative 4x minus 2h.
Wait, no, it'd be negative 3x, right?
Negative 4x
negative
minus
x squared minus 2x squared.
Your 3 should cancel.
Yeah, my 3's canceled. It'd be negative 3x squared, right?
You shouldn't have any squares left when you're done. Did you get to this point? Michael.
3 minus 2.
This is the start. Did you get this for x plus h? F of x plus h.
Okay, yeah. Yes, I have that far.
Okay.
That far I have, yes.
Okay. Now we just have to build our difference quotient. So 3 minus X 2 times 2x plus 2hx plus h squared minus f of x 2x squared over x plus h minus x. Yes?
Yep, so it's,
Distribute this negative.
yep. So negative 3 plus 2x squared.
And then I'm actually also going to distribute this negative 2.
So it's so it'd be 3
Minus 2h squared.
2. Good catch. It's the negatives. Negatives persist at being tricky from algebra 1 on.
So 0 difference. So then it'd be cancel. So it'd be negative 4x minus 2h.
Mm-hmm. Yeah, did you just not distribute your negative 2?
Yeah.
Okay.
The negative 2, yeah.
Okay.
2.
I distributed the 2, but I didn't distribute the negative.
I distributed the negative, but not the 2.
Well, that'll do it, yeah. Okay. Okay. And then you already did 16, you did 16. Okay. Okay, all right, that's good. Caught up on that. Trying to make sure you have those notes correct. Okay, let's keep practicing this difference quotient. So the difference quotient is so important because it's about the slope of the secant line. Okay, so I'm gonna spend, before we practice, a couple minutes reminding you of why we're here and what we're doing. We've spent like 4 weeks almost trying to begin understanding how to solve the tangent line problem. How do you find the slope of the tangent line at a point? If you only have one point, how do you find the slope? If you have the slope, we already found it. And to find the slope, what do you need? 2 points. 2 points. So it's not even a tangent line. So we're in this loop of how do we find the slope of the tangent line, but we can't have 2 points because it only passes at 1 point. But I don't know any other points along the tangent line because I just made the tangent line. So I don't know for sure if it passes through here or not. I can estimate, get a guess, but I can't know for sure. So that's what we've been trying to solve all along, is this tangent line problem. Because then if I know the slope of the tangent line, then I'll know the rate of change at this point. And so we're trying to figure out what is the behavior right here, but we're running into problems because we can take the average rate of change for 2 points. We could do a table of values and find the average rate of change. We could be given the slope of the tangent line and then we would know, but how did we find out that slope in the first place? This is the question we're seeking. So all that we've been learning so far about derivatives is leading up to this. There is a way that we can find the slope of the tangent line at a point. And everything we've learned so far, it's going to get us there. What I want to do is practice this average rate of change on graphs and see what we can find. See if we can discover how to do it. I think you guys can. You're so close. I'm so excited for you guys. You're like really close. It's going to make everything so much easier because we don't have to do all of this estimating. Okay, so let's see here. We have, what did I put in here? This is x squared plus x is this function. Let's try to see if we can find the derivative, the rate of change right here at 1, 2. That should be 1, 2. Yep, 1, 2. Okay. let's see if we can't find the average rate of change nearby. We can use what we just learned from that video to find the average rate of change here. I'm seeing like right here, it looks like it crosses a nice little point. We could try to use that. It looks like right here it passes a nice little point. We could try that. You see those?
Mhm.
So right here and right here. If we take the secant line there, that's gonna be pretty close to the tangent line. So let's estimate that. Use your difference quotient and do it. The f of x is x squared plus x. So we'll need, okay, let me connect this better for you. We need our difference quotient of, well, you could use the one that are on the very front page. You know how to use those. That's an algebra 2. Or if you want to use the difference quotients with the x plus h's, you could do that as well. The h stands for the distance between this point and this point. So the x would be, where am I? The x would be, looks like 0.8. And then h would be 0.8 plus 0.4. So the h would be 0.4. Are you with me or are you totally lost? Seems like you're
That makes
okay.
sense.
Got lost.
Okay, no problem. Here we go. If I have, here we go. I have a point here and a point here. I'll label that one x, and this will be f of x. Can you see the board? TV's on, okay. So this point is x, f of x. Okay, so there's that point. Right here, rather than calling this like x2 or a, whatever, let's just call this distance h. Instead of labeling this, we'll call this x plus h. Okay? So then this point would be f of this point, which is x plus h.
Oh.
Okay?
Okay.
So if we want to find the secant line through these 2 points, then we'll just use our difference quotient.
Oh.
But with this fancy notation rather than like y2 minus y1. We could do that, but let's use the fancy notation. And so that's why our difference quotient is y1 minus y2, which is f of x. Those are 2 y's, and then here are your 2 x's.
No way, so it's just.
So this is how he got that in the video. So that little manipulative in the on the website,
Yeah, I remember.
that's this. This is what he built. But like a dynamic one. That's not on a whiteboard.
No way.
Yeah. Crazy, right?
Wait.
So we can use this. This is called the difference quotient. Which, by the way, so we can just write it as
Over h.
okay. If we want to find this secant line using the difference quotient here, I should find a way to just put the points in here so I don't have to like keep referencing it. If we want to find the rate of change right here, we can estimate by taking the secant line of something really close. How about right here and right here? Those are our 2 points that we can know to find a slope. So then we can plug those in here. Take a crack at it.
So it's.
What will be our x right here?
0.8 and 1.4.
0.8, and then yeah, our y would be 1.4, yep. And then right here, we know the x, but what's the h?
Wait, how do we know the x again?
We know the x because this is where we start. So we
Oh.
started at 0.8.
Yep.
Okay, so then what is here? What's the h value of this distance?
It's just the difference between the x value and the second one.
Right.
Sorry, first.
And so the second one is at Yeah, it's really hard to show you, but 1.2. Okay.
So then it'd be -2. Sorry, -0.2.
The h value is
Wait, pause.
1.2 minus 0.8.
Oh. 0.4, right?
So yeah, so h is 0.4. Yep. So now we have x, we have h. Now we just plug it in, and I already gave you f of x is x squared plus x, or yeah, plus x. Yep. Okay.
Wait, and then
So
so
then-
sorry, the
I'll see. Can he see this in the video?
Yeah.
Okay, good.
so the one on the left, f of x plus h, that is y1, correct?
Sure, doesn't matter. You can call this 2 and this one 1. Doesn't matter.
So then our equation would be 0.8 plus 1.4
So
minus 1.2
you have what?
minus, oh wait, this would be the y value. So if we-
Yeah.
So
Is that what you said?
yeah, is that just what we would have?
Yeah. No. What does this make? What's the slope of this secant line? I actually have no idea, so you have to tell me.
Should be 3, I think.
3.
I think. Yeah. Maybe.
Yeah, that's right. Yep. Doing it in my head. So that should come out to 3 when you put it in a calculator. Because you would plug 1.2 into x squared plus x. And 0.8 into there. Whatever that comes out to, divide that by 0.4, you get 3. You with me?
Yes, I am just trying to write it down so I don't
Yep.
forget this.
Great. That's totally fine.
So this would be
An alarm will go off on there in a couple minutes, just so I can read.
so the point on the left, it really doesn't matter. It would just be so another way of thinking of
We
this,
will always want to do this one first and then this one, but if you're thinking about it in terms of y1 and y2, it doesn't matter which ones you number those.
Okay.
But we will always want to do this one and this one for the h ones. So, otherwise, yeah, I mean it'll work out differently. You'll just have negatives to work with, which is not fun. So. Okay. Okay, so we can like the slope near there should be 3.
Mm-hmm.
Okay, so we can estimate that way. What if we do a different point? Let's do like, let's see. Oh, here we go. It crosses right here. Let's try to find the derivative of here using the secant line. Okay, I'll give you a random point on here. I'll give you this point. I'll try and hold it still. Ah, it moved. I don't know where it was.
1.32.
Yeah, that one. I'll try and hold it still. 3.0624. Okay, so write that down, that point. You have to copy from LCs now.
1.32. 3.0624.
Okay, and then I'll just give you this random point at 0.34. Maybe. There we go.
2.34.
2.34, 78156. 7.8156. Oh, it keeps going away. I'm not moving.
7.8.
Okay, now use those 2 points. Find the secant line between those 2 points. That'll estimate our slope, because we went from here to here, it'll estimate our slope at this point. So use that difference quotient, estimate those. Really, you could just use y1 and y2 because I gave you those points. That's fine.
Yeah.
You don't have to do the h version for this one.
I'm gonna try to use the H one. 'Cause I'm
Sure.
trying to search on it. So
Yep.
to do that,
Great.
it would be, the numerator would be 1 point, it'd be 3.06 minus 7.8, right?
I don't remember what they were at all.
Those are the y values.
Okay, what was the first point?
1.32 and then 3.06
Okay,
and then 2.34 and 7.81. 7.81.
7.81.
Yep.
Okay, all right. You could just use y2 minus y1 over that if you want to. Okay, but if we want to use the x version, we'll say that this can be our x, and then the distance between this x to this x is our h. So we'll take this minus this to find that distance, which is
9.2. Oh yeah.
Yeah,
Oh yeah.
1.92.
I think this.
Yeah, that's right.
Okay, yeah. All right, so our x is this, our h is this. Okay, so now we would do f of x plus h. X plus h is this, minus f of x over h, which is this. Okay. Then f of 2.34 is that. F of 1.32 is this, over h. Okay. What does that come out to?
Okay.
It's about 4.65. 4.66.
About what?
4.66.
Okay. So the slope there of that secant line, this is the slope of that secant line, it's 4.66. Okay. What if we move the points closer than what we had to this point? Let's move those secant line points closer. Maybe we could get a better estimate. I'll give you this point. No.
Okay, so the secant line is, so if they ask you to try to find the slope at that line, one way you can do it is the secant line of two lines that are 2 points that are above and beneath that one, right?
Yeah, that estimate the tangent line. It's not going to be.
So yeah, so
And
the
the closer
tangent,
you get, the more
The
accurate
closer
it'll
we
be.
get. Okay, interesting.
so the tangent line is the slope at the point itself, and the secant line is the line that connects 2 points that are on either side of it, right?
You're right.
Yep, because the secant has to have 2 points that it crosses the graph. So, yeah, if those points are really close, we can get a pretty good idea what the tangent line is. Okay. So yeah, what if we move those points closer to, you know, right here and right here? What if we move them closer to like right here and right here? What if we moved them even closer?
It'll just become more and more accurate.
Become more accurate.
Closer to the actual.
Could we always get closer and closer
It's a hallway.
and get
Dang
more
it.
and more accurate?
Yeah.
It is a hallway.
We gotta stop it with these hallways.
We gotta stop the hallways. Actually, we love the hallways because what does the hallway represent? Mathematically, what do we do that the hallway told us about?
Infinity.
It was like a really, it's like infinity within bounds.
Yeah, pushing finite to the infinite. Yes. What have we been doing that's been pushing the finite to the infinite?
Division.
On your exam. well, think about it, I guess.
What are you doing? That was perfect, Lauren.
Maybe the alarm never went off because it's recording. We stopped the
Probably.
recording.